Suppose that a and b are positive integers. We want to prove by contradiction that if a is less than b and a times b is less than 3, then a must be 1, right? So remember, this is of the form if-then, so this is P implies Q. So a proof by contradiction is we're going to assume the negation of this, and then we're going to prove that the negation of this is false, meaning that the original P implies Q is true. And remember, the negation of P implies Q is logically equivalent to P and not Q. So if we can show that P and not Q is false, then that means the negation of P implies Q is false, which means the original P implies Q must be true. So let's go ahead and start this proof. So we're going to suppose, of course, that A and B are positive integers, right? But we're going to suppose that A is less than B, basically P here, right? We're also going to assume that A times B is less than 3. And then we're going to assume not Q. And we're going to assume that A does not equal 1. Right? So, since A is a positive integer, right? And A does not equal 1, this implies that A must be greater than or equal to 2, right? It is a positive integer that's greater than or equal to 2, right? Okay, so I know that A is less than B. So if A, right, so let me just go ahead and scoot this here. So if I know that A is less than B and that A is greater than or equal to 2, right, this means that B must be greater than or equal to 3. It can be 3 or bigger, right? Okay? So now I know from my assumption that A is not equal to 1 that A must be bigger than or equal to 2. And from my assumption that A was less than B and that A is bigger than or equal to 2, that means B must be bigger than or equal to 3. So, of course, this implies that A times B is going to be bigger than or equal to, so 2, right, for the A, times 3, right, which is, of course, 6. So this means that A times B must be bigger than or equal to 6. But hold on, we assumed that A times B was less than 3, right? But A times B is less than 3. And this is our contradiction. Because per positive integers A and B, A times B can't both be bigger than or equal to 6 and be less than 3, right? So that means P and not Q is false, which means the negation of P implies Q is false, which means the original P implies Q is true. And that is our proof.